Another one of the cornerstone protocols to make the TCP/IP protocol suite work is the Address Resolution Protocol, or ARP. Now, ARP, what it does is takes a known IP address and figures out what the MAC address is. So if I know the destination MAC address for something that's on my network, but I don't necessarily know its MAC address, I can send a broadcast on layer 2. So it's a layer 2 broadcast, an all Fs message, saying, I know this IP address. What is the MAC address of this particular device? So we send a broadcast. Everybody on that particular LAN segment is going to receive the broadcast. Most of those devices are going to throw it away. Only the one device that actually has that IP address will respond back and say, this is my MAC address. So if you take a look here, what we're seeing is the client is making a request for 192.168.1.14. As we send the broadcast out, the other machine is saying, oh, that's my MAC address, and he's going to respond back with that message. Now what we have is, after this goes through, I'm going to create an ARP cache on the actual client. Now the ARP cache should be there for 7 hours. Of course, I don't know what happened at Microsoft. Maybe they didn't read the RFC, but Microsoft clients only hold on to it for 10 minutes. But needless to say, the ARP cache is supposed to be there for 7 hours. At least that was the last time I looked at the RFC. Maybe they changed it. Who knows? Okay, so that's ARP, very important part of what we do in IP. Without it, we wouldn't be able to build a layer 2 frame, an Ethernet frame, if you will, so we could talk from client to client on an Ethernet segment. I want to make one note here before we go on to the next area here, and that is about default gateways. Again, one of the things you have to have in order to make your TCP/IP addressing work on a particular machine is to have a default gateway. Now, you don't have to have it unless, of course, you want to talk to anywhere else other than your own local network. But what's interesting about the default gateway IP address that a lot of network administrators don't realize until they're told is that the clients very rarely ever talk to the IP address of their default gateway. Only if that client just so happens to be the network administrator's machine and they're SSHing over to the router, will you ever use the IP address of your default gateway. 99.9% of the time, what your machine is going to do is going to ARP for the default gateway so it can build a layer 2 frame to the gateway itself to talk to a remote IP address. So when you're trying to talk to somebody that isn't on your same network, you're going to send a layer 2 message to your default gateway so that the router can figure out and route that packet to the remote LAN. So the default gateway IP address, coincidentally, isn't used on your client other than to ARP for the default gateway and to create a layer 2 frame to get there. So now that we've talked a little bit about the network layer, let's go into layer 4 and talk about the transport layer in a little bit more detail here. So I mentioned the transport layer. We're going to talk specifically about how TCP and UDP work. We have the choice of being connection-oriented or connectionless here. We are talking about host-to-host communication across a network, again, regardless of the size of the network. We have the options of making our data reliable or unreliable. And you think unreliable probably would be a bad thing. I'm going to explain why having data unreliable would actually be a desirable thing in your network. We also have some options of doing flow control and other things to control how many segments we're sending between devices before we expect a response back or acknowledgement that we've received those. So this is the transport layer, so let's talk about these two protocols specifically, TCP and UDP.